video we'll be looking at the components of blood. So what is in blood and what do these components do in blood to allow the cardiovascular system to be really good at its job. Hello, today we are making blood, or a blood smoothie. For red blood cells, I've got some raspberries cut in half. Now, I've deliberately done that because by looking at the raspberry cut in half, we're slightly mimicking the shape of a red blood cell. Now, a red blood cell, if you actually look at it, it looks more like this. And the shape you see is is biconcaved, so it's got like a little hollow either side, and what that allows for is it to do its job efficiently and carry oxygen. So you can see there I've got a little vitamin D tablet which is representing oxygen, so it can carry oxygen for you nice and easily, and that is its only job, is to carry oxygen. It has a component called hemoglobin which helps you do this, which is an iron protein molecule. So that sits within the red blood cell itself to hold on to the oxygen for you. Representing platelets, we have some bits of mango. Now you can see I've got little cocktail sticks through the mango. Obviously I'm not going to put that in my smoothie, I'll take that out before. But in terms of platelets, they're quite good for representing platelets, because what platelets are able to do is they're able to stick to each other. And then as a result, when we cut ourselves or break a blood vessel, the platelets will surround the area and link together and form a scab, a blood clot. Next we have our marshmallows, which is our white blood cells. So as I just said, a marshmallow is representing that white blood cell. Now their job is to fight infections and diseases. So here we have some pathogens, which aka like baddies. So these might be the viruses or the bacteria that's got itself into your body. And what a white blood cell will do is it will engulf the baddie. So they will engulf the baddie. So you can see here, they're swallowing up. And that's white blood cells. And then we have plasma. Now I've got three different items here representing plasma. Now we've got a big glass of water, because plasma is mostly water. We've got a glass of orange juice, which is representing byproducts, so waste products. So it could be lactic acid, it could be urea, it could be other types of acid, but that is our waste products. And then we've got sugar, which is representing nutrients that the plasma carries. So for example, glucose, vitamins, etc. So and then basically it's all just mixed together, and this is what makes your blood liquid. Let's make the smoothie. So we need some red blood cells. Put them in. Not forgetting the oxygen molecules that they're able to carry. We need some white blood cells. Write them in. We need some platelets. Let's blend it up. Now we have a slight issue. It looks nice and red, but it doesn't look like blood. Now, if we imagine that the blender is the heart, and as it goes, it's pumping blood around the body. So this would represent, all our blood vessels and body. Now, if we set our heart off, not really pumping anything anywhere. So we've got our red blood cells in there. As you can see, it's nice and red. We've got our white blood cells in there. We've got our platelets in there, but it's not actually going anywhere. So that's because we are missing our vital component, which is plasma, which actually makes our blood liquid. So let's add the plasma. So we've added the plasma. Let's set our heart off and see if it actually pumps around. Or not. Now look at that, ready? Heartbeat. Blood gets pumped around. Heartbeat. Blood gets pumped around. So now we're able to deliver oxygen nice and fluidly. We're able to get to all the areas that need repairing with the platelets. We can get all those white blood cells to the places where the bacteria has got in or infections have got in. So that's blood. So let's go over a few scenarios then. So imagine you were immune deficient. So here's some white blood cells. Well, you'd have less. Imagine you were dehydrated. So do you remember how important plasma was to make it all flow around? Well, instead of this being your plasma, this would be your plasma. Let's imagine you were anemic, so you didn't have enough iron to make the red blood cells. So remember, hemoglobin is a component of red blood cells that helps us carry oxygen. So instead of having all of this red blood cells, you would have, get one more. And then we have our two different blood smoothies. So if you look at this person here, this was the person that had adequate amount of each component, or this person had less of each component. Now, look how much more red blood cells, more plasma, more white blood cells are going to get round the body compared to this person. Also as well, look what's started to happen. So this person is going to be far more efficient at delivering oxygen, fighting off infections, and also as well as actually getting it there to all parts of the body. Last scenario. So now we've got someone who's super health conscious. So here's their blood. Okay, and they've been training for 6 weeks. So they've been doing continuous training for 6 weeks. How is their blood going to adapt? Well, they're going to grow some more red blood cells. So now their blood is going to become thicker with red blood cells. So for each red blood cell that's going in, that means more oxygen can be carried. They've been taking vitamin D and vitamin C and been really conscious about improving their immunity. So they've got some more white blood cells that are going to go in. They've also been really conscious about making sure they're hydrated. So now their plasma is runnier, there's more water in it, so you've got more plasma. Let's blend it up. Lovely. Loads of oxygen being delivered, loads of blood clots forming from the platelets, loads of waste products being removed, glucose and other nutrients being transported, and loads of bacteria and viruses being got rid of. Thank you, blood.